The load shedding solution, a UPS or inverter. I think we all know that we need something to actually keep our systems going while Eskom gives us our dear load shedding. Right, so the agenda, and this is more or less what I said I would cover in the brief overview I gave you. What is a UPS and how they work? What is an inverter? How they work? When we use a UPS and when to use an inverter? How long these will keep me working on my PC? Estimated pricing, choosing your brand and supplier, and then how to measure the power that your PC uses, so you can determine what sort of backup device you need. As again I said, if you want to post any questions, please do that live or send me email at malcolm@techforlaw.co.za. Malcolm P, sorry. Right, so introduction. I am Malcolm Pearson. I'll gather from the invites you got, you have a clue who I am. I am the editor at techforlaw.co.za. There is my Twitter handle, which is techforlaw. And if you want to tweet anything about the presentation, please go ahead. Use the hashtag LawTechShare. And in Facebook, there's our Facebook address. Please forgive the little barking in the background. I wish I could change it. The poor guy is trying to keep the monkeys out of the property. Right, so what is a UPS and how they work? So they very simply is an uninterruptible power supply. Basically from your main supply, it goes into the UPS, and the UPS then feeds the CPU, or in our case, what we term as the computer. UPS types, so there are more types. I mean, some of them are broken down further, but basically we have a standby where there's not much cleaning of the power. It's a little bit slower to switch from the mains or the live feed to batteries. There's line interactive, where there is more cleaning of the power that comes in. When I say more cleaning, I'm talking about the dips, the spikes, etc. Things like when they switch the power back on at Eskom, and that will send through certain spikes. And it's also very quicker to switch from your Eskom power to your battery. And then the online systems, which give you a lot cleaner power with no switching, because they permanently using the backup system. If you want to get some more information, have a look at that URL. That will give you the types of different systems in more detail. And also, by the way, APC is one of the big distributors of UPSs, especially in South Africa. Right, inverters, how they work, basically converts low voltage, which is a DC current, to an AC alternating current. I said alternative current. I don't think it's alternative current. It's definitely alternating current. Typically, these systems switch from the 12 or the 24 volt to the 220 volt system or AC system that we need to run all of our systems in South Africa. Basically, if you want to make it simpler, from a car battery to a plug-in-the-wall type stepping up of the voltage. Right, so let's go back to the UPSs. The UPSs, the standby UPS, remember I said there were three major different versions of UPSs. The standby UPSs are cheaper. They're generally the smaller ones that sort of run one PC at a time. The inverter sort of backs up, only really kicks in when the mains fail. Has a transfer relay switch, which switches from the mains to battery, and ranges from between 2 to 10 milliseconds. The good thing about that type of UPS is that the inverter sits idle while the system's running on the mains. But as I said, there's not much power filtering on that system. An interactive UPS smooths input power, what they call a tap changing transformer, and also with a filter. It has a bi-directional inverter charger, which is always connected. And then basically when the mains fail, the input is switched over to the battery with the inverter running through that. So it's sort of it's in between the online and the standby. The online, the power input always flows through the inverter. So I must also say to you that all UPSs do have a built-in inverter, but obviously to a lesser degree. We'll talk more on those inverters in a couple of minutes. Then when the mains fail, there is no switching because the system is already going through that whole battery system with inverter, and so everything's smooth and it's always coming through clean on the other side. So basically what happens is a 250 volt, 220 volt in, switch to the 12 or the 24, depending on how many batteries you have and the battery sizes, into an inverter, and then back out again with 220 volts. Okay, so the upside of UPSs, they're generally cheaper than the inverters. There's a smooth change over to the battery. What can happen if your switch over from your mains to the battery is too long or too slow? What happens is your PC shuts down, and when the UPS kicks in, or more generally the inverters, your PC comes back to life. So basically that throws your whole idea of keeping your power smooth to your PC. You don't want to lose anything every time the power goes off. And it's also a very small footprint. UPSs come with everything bundled inside. Generally, let me mention that again. The UPS downside, the time on the batteries is short. Basically, it gives you enough time to shut down safely. Again, I say generally. We'll have more about that later. New batteries may be difficult to source depending on how they've been used in the system. They might have proprietary batteries that they've used or connections, etc. And just an idea, I think those batteries end up being, especially for the small UPSs, end up being as pricey as just replacing the whole UPS. PCs and notebooks, just while we're talking about the power, I need to give you an idea of what happens with these things. In PCs, they have what they call a switch mode power supply. And the switch mode power supply is taking your alternating current, converting it to a DC current to run your motherboard and your hard drives, etc. So that switch also helps with the system not switching off and switching on. And they say that it can handle a power dip for 16 milliseconds. So if you've got a UPS or an inverter that reacts before that 16 milliseconds, and they say the 16 millisecond is a standard that they set, the power supply manufacturers. But if it has a switch over time of less than that 16 milliseconds, there is a very good chance that you won't notice the dip in power and your PC won't switch off. Obviously, anything longer, like 20 milliseconds, that PC is going to actually switch off and switch on. The notebook, as you know, it has a battery built in. So basically, your notebook will actually swap to battery and then basically go back again when your UPS or your inverter sends that power. Obviously, your monitor doesn't have too much built into it, so I'm not talking about a switching power supply, but I mean that's a matter of the monitor switching off and switching back on again. No harm there. Then having a look at what an inverter does and how it works. Basically, when I'll try to get you the best sort of descriptive image here, the AC comes in from Eskom in our case, and basically goes into your inverter. Your inverter then has a battery connected to it, normally an external set of batteries, that it charges those batteries, and then through that system it then feeds your devices, PCs, televisions, etc. But I think the major difference with the naked eye we can see straight away is that the inverter in this case is separate to the battery pack, and that's what makes it a little bit more bulkier. So the inverter upside, they generally have longer battery lives, so it keeps your system up for a longer time. They're faster in charging because obviously when you use a system for, let's say, 2 hours, it's going to take some time to charge those systems back. And the older UPSs used to have sort of about a 2 amp charging, where your inverters generally have a charging time, with obviously inverters with built-in chargers have a charging time of about 10-20 amps. So faster charging. It also handles initial high startup power consumption much better than UPSs do. And you'll see normally with the rating, they'll have a startup rating of say 2,000 watts and a running of 1,000, where what it means is it'll take a spike when a machine's starting up to handle that 2,000 watts, and then it drops. It obviously then can drop back to its 1,000. And then also the nice thing about them is you have many different ways for input into that system, generally things like solar or battery or generator. And don't always assume that the generator gives you clean power. Often it's a good idea to go through an inverter to smooth that power coming out the generator, unless you have an inverter generator, of course. Inverter downside, normally these are bigger. Like I said, the battery packs are external, so they're more bulky. Those batteries come in external battery casings, or just generally these plastic boxes that you can get. The longer transfer time, the AC2 battery generally is longer than that of a UPS. The cheaper versions of the inverters have a square wave, which is then converted to what they call the modified sine wave. And I think my next slide, there we talk about the sine wave. So generally the UPSs give you a smooth sine wave, which is in the blue there. And then the modified sine wave is almost like a step in between a square, and the sine wave, which gives you that sort of step wave. So some TVs will have problems with that type of system because they end up getting noise. But yeah, maybe we'll touch on that later. The two types of inverters, like I said, the square wave, which is a modified sine wave, which is cheaper, causes noise on certain TVs and audio systems. You could fix this possibly with a small UPS just before the device, one of those 600 volt ampere systems. The pure sine wave inverter, this gives you clean power all the time, uses less battery because it's not converting that waveform all the time. And it's safe for sensitive components and motors. Like I said, they do also advise that you should only use pure sine wave inverters for things that have motors, things like fridges. Right, then, when to use a UPS and when to use an inverter. I was going to do these in different colors, but let's just get through them. To protect the PC from spikes, dips, safely power down when the power fails, a small little UPS is going to be fine in that instance. While you're using a generator to feed your PCs, if you want to clean that power, a UPS is a good idea. Running your PC for the entire 2 hours while load shedding is happening, you're going to need something like an inverter. Running anything with a motor during load shedding, you're going to need something like a pure sine wave inverter, like I mentioned earlier. Power that is off more than 2 hours a day, when you're going to need that fast charging, that is something that you will get from an inverter. When wanting to use alternative methods of power, then the inverter is definitely the way to go. We're talking about those solar or generator inputs. Devices that spike to start, like the motors, the inverter is the better one to handle. And they say sometimes you should look at between 2.5 and 3 times the regular load that it's going to draw when that motor starts. Quick and easy, if you want something that's very quick and easy to drop on the desk next to the PC and plug it in, a UPS is going to be the best solution. So how long will these keep my PC going? A UPS, when I talk about the general UPS solutions out there, they're going to give you 15 to 20 minutes, of course, depending on what loads you have. The inverter, you're going to get that 2 hours to 4 hours if you don't overload it. So basically, if they say 600 VA, you're running at 400, you're going to be okay for those 2 hours. Then a little footnote there, and it should be a footnote, not a big bold title. We're going to talk more of this at the end. So estimated pricing, the UPSs for your PC, 700 to 800 Rand. Like I said, the small 600, 650 VA type solution from Apex. That is UPS Direct. And I'm sure you can get them from other people too. Just look for the Apex brand. And then the 2 kVA at 2,325 odd. So there's the pricing there. If we look at inverters, and of course these inverters are going to give you a lot longer backup time, like I'm mentioning there. You're looking at 4,000 Rand for the 1.2 VA, which gives you 720 watts of power. That's 4,000 Rand, and that's a kit that comes with the inverter and the batteries. And if you're getting excited at this stage, don't, because stocks aren't available. I checked with Mustec, who are the suppliers of Mercer earlier. And then also the 2.4, you're looking at 6,000 Rand. So there are two inverters just off the top of our head with those sort of pricing. All right, choosing your brand and supplier. Right, so the suppliers, my advice is that you find or use your current IT vendor, a reputable one. If you're not using a reputable one, you probably should change to a reputable one. A big supplier who you know you can get decent backup from, or your reliable Sparky. So if you have an electrician that you use on a regular basis and you're comfortable that they're not going to take you for a ride or use inferior products, then speak to your electrician. On the brand side, the brands that are supported by the big distributors, like I said, the Mercer brand from Mustec. Mustec's been around for many years, so they're not going away in a hurry. And genuinely, they bring in products that they know they need to support. And I'm sort of going out on the limb here, but sort of any German brand, especially on the inverter side, when you start looking at solar power and that, German brands might be expensive, but they definitely are tried and tested and have high quality assurance. Popular brands, things like APC, like Mercer, like Apex, things like that. Look for a brand that is quite popular, and then check the websites. Have a look at the website of the people of the brand you're looking at. See what their distribution is like. See about their partners in the various areas. But you get a good feel from the website. And then also look at discussion groups. I had a good look at what people were doing with UPSs and inverters on a 4x4 forum. And I know 4x4 is not really got anything to do, doesn't really have anything to do with a UPS or inverter unless they take it for camping. But those guys are rather practical, and a lot of them have vast experience in actually using inverters and things like that. So that type of forum is always very helpful. How to measure power usage. There's a URL that you can use to go and have a look, energy use calculator. They sort of ask you what are you looking for, and you say you're looking at televisions, and it asks the size, and it tells you what the various types of televisions use, basically per hour, and then you can work out what you need from your UPS or your inverter. A desktop with no screen, generally you're looking at 100 watts per hour. So obviously, if you're going to use it for 2 hours, you're going to need 200 watts. A PC screen, 20-inch, LCD or LED, you're looking at 26 watts per hour. And then a 42-inch LED TV, 80 watts per hour. But you see how it shoots up if you have a plasma display. So yeah, be careful of, well, not be careful. If you've got a plasma now, you're pretty up the river without a paddle. But in future, if you're looking at that as an option, that's one of the things to consider is the power consumption. Wi-Fi ADSL router using 6 watts per hour, which is not a lot at all. Add that into something to power up. You could always stick a little UPS in front of it if you're worried. If you had notebooks that could keep you going for the 2 hours, put a little UPS on your ADSL router, and you've got connectivity with your PCs for the 2 hours. The printer on standby, obviously, these things go into standby. When they wind up to go and do their printing, they use 400 watts power. Of course, it doesn't use it for the full hour while you're printing, so you probably find if you look at what it uses per hour with printing the occasional 1 or 2 pages, you're probably only going to use something like 50 watts per hour. Right, move on to watts and volt amperes. Now, kilowatts and kilovolt amps are basically 1000 watts or 1000 volt amperes. That's pretty self-explanatory. DC has always been measured, and it's a standard in watts, which is volt times amps. So the AC that gets supplied to us has a drop in the power due to what they call reactance, and that's caused by transformer drops, etc. And that basically drops the effective power that we get, so that what we can use, and that drop is called the power factor. So it's generally 0.8. So when people say to you this system is 1000 watts, generally what you're going to get is 800, 1000 volt amperes, sorry, kVA. If it's 1 kVA, you basically going to get 800 watts out of it. Hope I didn't confuse you with all those numbers. I'm sort of starting to feel sorry for old Zuma and how he pronounces numbers. Right, so just to give you a quick idea what the Eskom charges are. Rand per kilowatt hour, that's basically what we're paying in Durban, and that's just an example we're paying in Johannesburg. And these are those, not pay as you go, there's another word for it, but basically your metered systems. Joburg, they seem to work a scale, and you have to specify where you're buying for, and then it moves up the scale. And the more you use, the more you pay per watt hour. Not like everything else when you buy in bulk. And there's the appliance usage document from Eskom if you want to have a look at it. These slides will be up on YouTube later, so don't stress that you can't get the link quick enough. It'll be up there, and you'll be able to see it on the Tech for Law YouTube channel. Right, so mentioning all of that about UPSs and inverters, at the end of the slide I said there was something that I wanted to show you. They call them the long run UPSs, and there's a good friend of mine who are very reputable IT firm in Durban, and they've been supplying these Apex Plus units for quite some time, and they have raving reviews from their clients, but also from them on how reliable these have been. Right, so if you're looking at a 600 VA, which will keep you going for 4 hours, which is a nice long time, so I'm sure that would handle any stage 2 sort of load shedding where you get hit twice in a day. 6,207 Rand 30, not really, so it's 602 Rand really. And then for the 1 kVA system, you're looking at 6.5, and then that last one isn't a 1 kVA, it's a 2 kVA, my apologies. That'll give you 2 hours with a 2 kVA running capacity, and that is 10,000. That's sort of 10,000 and some small change. But those are sort of the prices you're looking at for the long run UPSs. So so that sort of wraps up the slides that I have. Yeah, it's sort of those long run UPSs do seem to be the answer. You can actually add on to those systems to give you longer hours. There's a way of connecting extra battery packs. And just somebody's actually mentioned here on the questions, I see they're asking about the price of those batteries. So if you're looking at inverters or these long run UPSs, the battery that you're going to need, they talk about the 100 amp hour batteries. Those you're looking at about between 1.7 and 2.5, 2,500 for a battery, depending on the manufacturer. Obviously, the cheap and nasty you buy, you're not going to get as good a service out of them. It's just like your car battery. After a couple of years, it goes dud, and you need to replace it. Same with these batteries. Also, if you push them to capacity too often, you end up using your battery quicker. So you just need to make sure that you don't abuse it. So those are the prices on the batteries. They also, I went to Ellie's earlier today. They seem to have a nice solution. They call theirs an inverter pack, either the 1 kVA or the 2 kVA. And the nice thing with their brochure is that they tell you what appliances you can run and for how many hours off each of these systems. Of course, they didn't have stock at the time, so I couldn't actually get the official pricing from them. But yeah, so that was quite interesting from Ellie's. And just to give you, they said the estimate pricing was for this, the 600 watt or the 1 kVA at 6,200, including, and for the 1,200 watt, that was 8,500. So those aren't bad prices either, but those are purely inverters. And you see, with inverters, like I said, there is a changeover time. They call it the transfer time from AC to battery, and they were saying from 10 to 20. Now that's a little bit concerning, because if it's at 20, it means that the PC is going to switch off in between that dip. So if it's closer to 10, you won't notice anything. The PC will carry on throughout that dip. But as I said, if it's 20, there's a problem. So we might want to find some more information on that. Right. I'm going to wrap up now. It's just 1 minute before the half an hour. I'd like to thank everybody for listening and for the question that came through. What we'll do is tackle maybe some power systems going forward, and how we can use these systems in small law offices or at home. Thank you for your time.